Good afternoon, everyone, and welcome to today's webinar titled Integrating PdM Technologies from Design to Practice. My name is Taylor Colon. I am a Customer Engagement Specialist at Test Oil. I will be your host today. Before we get started, there are a few things I wanted to go over. First, everyone is muted. We are recording today's presentation, and by being on mute, this will ensure a high-quality recording. Second, please feel free to use the questions box in the GoToWebinar application. We would be happy to answer any questions that you have. Finally, the webinar recording will be distributed later today along with a survey. Look for that in your email that you registered with. Let's get started. Today's webinar is presented by John Facillo. All right. John is Executive Vice President of Global PdM Operations. Mr. Facillo has 31 years of experience in the design, implementation, organization, and operations of condition-based maintenance, condition monitoring products, and service management. He graduated from the Williamson School of Media, PA, where he received an associate's degree in electrical power technology and is a graduate of the University of Cincinnati College of Business Administration Executive Management Program. John, if you're ready, I will pass the controls over to you.
Super. Thank you, Taylor. Good morning, good afternoon. Appreciate everybody taking the time. We're going to get right into this. Today's presentation, we're going to talk about the integration of predictive maintenance. And in most cases, or at least in our experiences, most people deploy predictive maintenance kind of as each individual technology, whether it be oil analysis or vibration monitoring or infrared, and generally they're separate with separate reporting structures and separate analysis and functionality. Today we're going to talk about how to integrate those technologies into a cohesive program, and how do we go about that to make sure that not only do we have that program that's truly integrated, but it's returning on the investment. So we're going to get into it. I'm going to start the slides, and as we start, and hopefully most of you are familiar with the PF curve, but we're using the predictive maintenance technologies to help us get that early warning system, and different technologies will help us in different ways, but for us, we're trying to live at the top of the curve, or closest to the top of the curve as we possibly can, versus working at the bottom of the curve. So as we live at the top, you know, it's just giving us the maximum flexibility to determine the problems, to prepare, plan, schedule, and effect any corrective action that is needed, and we minimize collateral, if not catastrophic, failures or damage. But when we overlay that same PF curve, looking at some of the PdM technologies, and there's a few of them on the screen, you know, we're looking at where those technologies can help us with those early warning systems. But if we just implement one versus the other, or we're not truly integrated, we may lose the ability to detect certain types of failure modes early. You know, as a machine starts to push towards the complete failure mode, you know, other technologies could pick up, but part of the design and part of the conversation that we're going to have here directly is how do we address failure modes with certain technologies, and not all the failure modes would be addressed with the same technology. So that's part of the overall premise, looking at those failure modes and using the appropriate technology in an integrated approach. So really, when you look at it, and I just cleverly put this graphic together, and I hope you're all chuckling for that, but we're looking at infrared, vibration, oil, ultrasound, maybe motor testing, motor circuit, motor current analysis, those types of things. But generally, in most cases, I see them deployed as individual standalone programs with limited crossover. And we're really going to try to work towards that true integration. But when you look at the applications, there are some commonalities across the columns of technology. But when you look at across the rows, there are some common applications that we're going to try to leverage. And not to say that we're going to just over PDM it if you follow that. It's we're going to align our PDM applications to be the most effective. When we think about designing the program, and I've had the opportunity to be involved in a lot of companies' design when they first get started, and typically they, the typical approach is, and I've always called it a traditional approach. You match the applications with the technology. And one of the things that, if I look at a vibration monitoring program, obviously we're going to match vibration monitoring with rotating assets. We're going to primarily use infrared on electrical assets, oil analysis on large sumps, gearboxes, and maybe larger bearings, that we're going to align those in a traditional fashion. And that doesn't mean that that is incorrect or wrong. It's just we typically approach that as one size fits all. And again, as an example, we're going to deploy a vibration monitoring system, but we're going to apply it to all rotating assets in a monthly fashion or a quarterly fashion. And when we do that as one size fits all, it really helps to limit us in really figuring out what is the right prescription for that asset. When we treat it one size fits all, we're basically saying all the assets have the same importance or criticality to us, and they all fail in the same means, in the same time frame. And we know that that's not true, but we continue to deploy the technologies like it is true. When we look at a justifiable design, we're really starting with developing our design based upon equipment criticality, and then a failure mode, and whether it be developed through an FMEA process, failure mode and effect analysis, or if we're using historical data, whether it be work orders or failure data through a CMMS system or some other type of tracking method, we're trying to look at where the problems that we've exhibited in the past and how to best monitor those at the lowest cost. So there are obvious differences between the two approaches. But as you move towards justifiable, I think what that will help address is the challenges of budget, the challenges of, well, we got the program started, but we're being challenged to show the benefits. And sometimes that's a huge challenge for many of our customers and folks that we've been involved with. It, how do I justify my continued existence and the continuation of the program? So really, at the beginning of this conversation, we want to ask why should we integrate? And standalone programs, they are effective. There's no question. Running an infrared program or an oil program or a vibration program can be very effective. The tools that we utilize for those programs are different. The models that we use to deploy them are different. Training is different. Skill sets may be different. I mean, I just created a list that argues against the why integrate. So I guess the point that I'm making is it's not necessarily wrong to manage PDM in individual silos. What most of the folks that I talk to want is take their PDM program to another level, to a next level. And this would be more along the lines of bringing us to that next level. Why do we want to integrate? We want to get more out of the technology. We want to get a better return on investment quicker. So it's not that we're arguing against wrong versus right. It's really, we're arguing about a progression of, we've implemented this and now we want to be able to achieve more and better results. One of the primary things that we want to do is integrate the analysis. We have complementary technologies that I think will give us a clearer picture of the overall health of an asset. And a great example of that could be journal bearings or gearboxes. You know, here any one technology may not tell us the full picture of what's going on in the full health of that asset or piece of equipment. Journal bearings are, you know, if we're deploying, say, vibration monitoring on it, and a white bearing may show up in a vibration signature that shows that it being in unbalanced condition. And truly, the way to determine whether it's an unbalanced or a bearing problem, and the most direct way would be to supplement that or complement those together with oil analysis and vibration together. If we're seeing wear metals in the a significant increase in wear metals and trends in the oil, we're going to lean more towards the bearing is opening up and it's the machine is not becoming more unbalanced. We're also going to use our trend analysis for that. Gearboxes, similar approach. If I'm on the outside of the gearbox with an accelerometer trying to measure what's going on inside the box, a lot of times I'm not getting a good transmission of that energy, that vibration energy. We need to supplement that with other technologies, maybe infrared on the box, maybe oil analysis on the fluid inside the box, those types of things. So that integrated analysis, but it's not just doing vibration, oil analysis, infrared. It's taking the results of each of those and really, as an analyst, looking at those to help diagnose the health of the machine, not individually, but combined. We also can use the integration to help lower our cost. And we'll talk about that a little bit more further in a few slides, but where we're using lesser costly technology to help us determine what we're trying to get out of the program. And a good example of that is if you operate large conveyor systems, and that conveyor system has a lot of rolls and a lot of bearings across it. Do we want to spend the time utilizing vibration and the higher cost of vibration, or do we want to deploy maybe thermography and look for hot bearings, or ultrasound and look for lubrication and bearing conditions that way? We can deploy them quicker, easier, and in some cases we can even integrate that into a autonomous maintenance or a TPM approach and engage our operations team to help with some of that activity as well. So looking to lower the cost by integrating the technologies would help. One of the primary things, and I just mentioned it a little earlier, is identifying failure modes. Not all failure modes are going to be identified by every technology. So sometimes we have to integrate if there's failure modes we must detect. And the more critical those assets, the more critical that integration will become. Another part of integration is timing of the data. A lot of times I see folks out there that have a vibration program and an oil program and other programs, but the data isn't timed together. So I may take a monthly oil sample and I may take a quarterly vibration. But when I acquire those samples, they may not be at the same time. If there's a significant time delay between one sample or the other, then it lessens the effect of that integration and in the analysis. So when we integrate these technologies together, now we're going to time the inspection. So when I pull an oil sample and when I inspect it for, say, vibration, I want to time those so they're happening at the fairly similar time historically. So maybe not the same day, but maybe within a day or two. If we could do it the same day, that would even be better. And then looking at how we can integrate that to track the effectiveness of the program and report the findings. Sometimes it's challenging. Sometimes just reporting it as standalone is challenging. So integration of those results is sometimes a lot harder. So if you think about these last two slides, I said why integrate, and integration is hard, but there is a value behind it. So if you're looking for that next step, or taking your PdM program to the next level, or designing it with this in mind to take it to a true integration, these aren't easy tasks, and they're not easy to overcome in a lot of cases. But I believe that there's a value and a return if you make that investment. So if we look at setting up the programs, whether you're looking at a standalone deployment or an integrated deployment, these steps really shouldn't change. Sometimes if we're looking at a standalone deployment, we don't go through all these steps. Like I said, a lot of cases we just treat it one size fits all. And as I go through and visit with clients and I look at their PdM programs, things like that give me kind of set off red flags. If I look at a vibration program and I'll see that every asset's collected at the same frequency, or all the alarms are the same across every machine, it kind of tells me that we didn't go through a kind of a thoughtful process of setting up that program, and we're treating every asset the same way. And that's really what we're trying to solve, is looking at how that machine operates, how's it fail, and then designing the right technologies and the complementary technologies to be the most effective to determine those failure modes in the earliest fashion. So just a simplified flow of that assignment of those PdM disciplines, and it really isn't a specific discipline. It's just we want to determine the equipment criticality. We don't want the program to be one size fits all. There are assets that don't demand this effort. They're less critical to the operation. They have minimal impact to the throughput or whatever the production is, and they're basically should be treated as more run to failure versus something that we apply a proactive approach to. So we want to challenge the criticality and then categorize the equipment for those pieces that should be applicable to a PdM and those that are not. And when they're not, we want to just apply other. They could be just basic care, just basic maintenance strategies, some routine cleaning, and maybe basic PM, or determine it's a run to failure asset. But if it is applicable to the PdM and it's critical enough for PdM to be applicable, then we want to go through a process of which is the second diamond to the right, of choosing the right technologies that gives us the most effective means of determining the failure modes. And I skipped over the cost, because it's really the most cost-effective means. And again, we'll talk about that later. But that second diamond is at the heart of our conversation as we move forward to the next few slides, is how do we accomplish that second decision point. So criticality being the first one, you'll have to have a tool. I'm showing you a screen grab of a tool that we use at Predictive Service. This is one that does like many others. It scores each asset. In this case, we have 9 elements of the scoring system. And there's all kinds of different tools out there. Whichever one you use, the main emphasis is we're going to try to score every asset and then categorize them. Once we categorize them, we want to put them in categories and then describe or prescribe the effort that we're going to apply to those categories. So the categories are the columns, A through E in this case, and then the strategies are the rows, all the way from reliability analysis down to the highlighted row, or the row with the arrow is the PdM category. Where would we want to apply PdM? So in this kind of example, we would apply PdM approach to any asset that fell in the A, the B, the C category. If it fell in the D and E, it would not be applicable to PdM. There's just not enough to give us a return on investment. And you could see that there's not a lot of X's in those last 2 categories. They're really just some basic care and run to failure approach. But as we move up the criticality chain, now we're going to apply a lot more formal reliability and maintenance strategies to those assets. We get back to, so we've gone through the criticality, we've determined where PdM is applicable. Now we move on to that cost-effective means of addressing the failure modes. So how do we determine failure modes, and what are the failure modes? Well, we want to look at mechanical, electrical, performance related or operations related, process related failures. We also want to consider the time, the duration from inception to failure, the cost or the risk of collateral damages, and the overall cost of failure. Some of those, depending on the criticality tool you use, will accommodate those last 2 bullets as well. One way of determining failure modes is doing a formal failure modes and effects analysis. And again, going back to that matrix, we're going to prescribe an FMEA on certain levels of criticality. FMEA can be a long process. It's a very man-hour dependent process. It's a time-consuming process. We don't want to just deploy it across every asset. We want to really go after the assets that really have the biggest impact and really have the biggest chance for us to be successful in a reliability strategy and to get a good return on investment for our PdM. In this case, I've taken this worksheet, and I know it's probably difficult to read, but there's a column that just highlights all this predictive maintenance or condition-based maintenance activities, and as we just filtered to those activities. Once we finish the FMEA, now we've got our work scope for our PdM program. And then we work to deploy those PdMs to address each of the failure modes that's identified for that system or asset. Another way of developing that failure mode without going through a formal FMEA is really just going back and either interrogating your maintenance management system and work order history, looking at, especially if you're using failure codes on your work orders, looking at how equipment failed. In a lot of cases, we're just using the legacy knowledge of the individuals that operate the facility to say, yeah, this type of asset, we typically get hurt by this type of failure or that type of failure. Even that will help us kind of zero in and pinpoint our efforts to really affect those reoccurring failure patterns. I like to talk about reoccurring failure patterns because most predictive maintenance programs address those reoccurring patterns. It's a separate subject that how do we address those reoccurring patterns, but we want our PDM program to be able to handle those reoccurring patterns, because in most applications, those patterns are the ones that we're going to attack. And they're the ones that are going to give us the greatest return on our program, because they're the ones that are really causing us the most pain now. But regardless of how you get to determining the failure modes, whether it's an FMEA or whether it's through just kind of empirical knowledge and legacy knowledge, we want to get to a point where we have the assets and defined by criticality, and then defined by what's prescribed from a PDM scope perspective. And just focusing on the last 5 columns of this table, we'll have our vibration, our IR, our oil, motor testing, and ultrasound. So if we deploy this type of matrix through criticality and some type of maintenance interrogation of failure history, this matrix becomes our PDM deployment model. Then we're going to start looking at how do we deploy this in an integrated fashion, and how do we time the collections so we get the maximum advantage of all of this information in a similar time frame. So when we're looking at the deployment models, a couple things that really make your programs more effective is training your resources to be multi-skilled. We don't want somebody to operate the IR camera and the vibration data collector and a lubricator pulling samples. We want the more multi-trained individuals, the more they understand of the different disciplines and technology, the more they can relate the findings of one discipline versus the other. So getting multi-skilled individuals in our program is a big enhancement. Enhancing that workflow and scheduling, I've mentioned this twice now, is the timing is critical. Getting a vibration signature and an oil signature, an oil sample, 30 days apart may not really help us with that integrated analysis. Timing those so they're closer together will help. Really getting to a point where we're using all of this information to either create work orders or to affect a report, so somebody can then make decisions on what maintenance actions should be taken. Again, this is a hard challenge. How do we report different technologies in an integrated fashion so somebody can make a decision on the next steps or the recommended action that should be taken? But if we solve that challenge, now we can then enhance our key performance indicators and tracking the effectiveness of our program. But really, when it really comes down to it, I believe that just that integration, that the extra work that's involved in that integration and the extra steps that you have to go through will really pay off when it comes to the effectiveness of the program, how integral the program is to the success of your facilities, and really makes your PDM program in general more valuable to your organization. So when you're making those technology choices, we've talked about this, we've shown it on slides. One thing that I put in there is it's not a technology as much as each one of these technologies has a person behind a camera, a data collector, an oil sample, a PDMA unit or a motor testing unit. That visual or sensory inspection as part of that should not be discounted, should be enhanced as far as the reporting and identifying potential problems in the field. We actually give it its own failure code or reporting code in the work that we do for our clients. It's that important to the success of the program. And there's a lot of things that we find from visual inspections that help us do technology analysis better, because we're aware of conditions that are visually determined or sensory determined, whether it's hearing, sight, smell, those types of things. When we look at those technology choices, and again, I apologize, just I took screen captures. I know you can't see the details, but I put a little green box around a report, and this report is looking at one asset. It so happened to be a cooling tower, and that asset had problems on 3 different disciplines: motor testing, oil, and vibration. Now, in this case, it was done purposely, but the timing of those problems were at different times. And actually, the motor testing was a month preceding the vibration and oil. But integrating them into a report, now I can open each one of those 3 individual problem reports, and I can look at them on my screen and say, okay, what is this one telling me versus that one, and how can I take all of this information and determine the overall health of that asset. So we use a web-based system to help integration, but being able to pull each of these technologies into a reporting system, that not only the reporting system, but for the analyst to look at each one of them in a common platform is very useful and sometimes critical to the success. Another way we want to look at making our programs more valuable to our organization, and it does go with integration, is using complementary technologies. And in this case, I just cited an example of using ultrasound and infrared, and really to help both determine electrical problems or electrical conditions. But the ultrasound integration is to help aid in safety. So we can listen to the electrical device before opening it. And in some cases, we're only listening because we're prohibited from opening it through either its arc flash rating or some other interlock system or some other restriction. But when we combine the two, if we listen to the electrical panels and determine if there's any arcing or other electrical problems, it may give us a different approach when we open that panel, or maybe we determine, since we heard arcing or corona inside, maybe we don't want to open that panel energized. So it's really a safety aspect, or it could be deployed on assets that we can't open, as I mentioned before. Other technology combinations, infrared, and this is infrared and ultrasound again, but in this case it aids in the diagnostic, and the example here is with steam trap testing. We can use them complementary, maybe using ultrasound as the primary technology to determine a failed trap or a leaking trap, and then maybe using infrared as a more complementary technology to just help fortify the diagnosis. Sometimes it gives you more of a visual view. It's a little bit easier to understand. Typically, when you do an ultrasound report, you've got a digital image. It doesn't really say anything. I mean, we're reporting sound or dB level, and we're saying the trap has failed. Obviously, an infrared view of it could show that more visually and help people really get their arms and heads around the problem and say, okay, I see what you're saying. I know we need to change this trap. I mentioned it earlier, using sensory inspections can help us determine other problems, and I've just highlighted a few that we've come through, and some of them are they're not related to the assets themselves, but as we're deploying human resources out to do these inspections, we should identify some of these problems. They could be failures waiting to happen. You know, overloaded lugs, dirt and debris. That was actually in a I think a retail office or a shopping mall, where birds build a nest in an electrical panel. And when we opened the external panel, we saw that. That could be a fire or a failure waiting to happen. And it also says that there's access, that these birds have been able to get into these electrical panels. So we have to look for the source of that as well. But using our sensory inspection really can help us, and we kind of make that as part of our technology. It's really not a technology, but our guys and your folks, their experience counts, and we should leverage that. You know, when we look about that technology choices, one of the biggest pushbacks is, well, I can't afford to do all those technologies, and that's really where we have to start looking at how the deployment model works, and make sure that we're making the right choice for the right reasons for the right assets, and it's really a balance, and sometimes the balance even creates a need for a combination of in-house and outsourced resources. So you may not be able to afford all the technologies in an in-house deployment, but you're going to combine some of the technologies with, you know, maybe you're going to do some primary vibration and oil in-house, and then you're going to leverage third parties to do others. So it may be a combination. It really is going to depend on the budget, and then the things we talked about earlier is the criticality and the failure modes we're trying to determine. But looking at some of those technologies, and looking at the one thing I want to talk about is how some technologies can be more versatile than others. So if you're budget constrained, where can we bring in a technology that can go across many applications? And two primary examples is infrared and ultrasound, where we can deploy infrared in multiple applications, whether they're in electrical systems, mechanical systems, whether they're in piping systems, building systems. We can deploy it in a lot of fashions, but we pay a little bit of a premium for that, because if we remember that PF curve at the beginning, the heat is really the last thing. It's much closer to the failure point when you start seeing the thermal anomalies than some of the other disciplines. So if we're budget constrained and we're using versatile tools, we may want to consider that as well. Even though that this can go across many asset types and applications, it's really pushing us down the PF curve. Conversely, we look at ultrasound that can go across many asset types, steam piping systems. We can look at bearing, lubrication conditions, things like that. But that has a tendency to push us up the curve. But the good news with both of these technologies, the cost of entry has declined significantly. Ultrasound devices have gotten really affordable. Cameras have gone down tremendously over, say, the last 20 years. Cost of deploying a camera is, well, now they've put plug-in modules into your iPhones and your Android phones that you can do infrared right from your mobile device. So we're driving those costs down, and so if budget's the problem, maybe deploying ultrasound and infrared across multiple applications can be a good starting point of that integration. Ultrasound can also help us with lubrication issues and lubrication practices as well. So, when you think about versatility of disciplines, ultrasound can cross over a lot of things and bring a lot of value. So, I know we're talking about integrating the technologies, but again, I want to be realistic that budget is a factor. So when budget is a factor, we want to pick technologies that can go across multiple applications as well. And ultrasound can aid us in not only determining problems, but also helping prevent them by lubricating our bearings properly. And another example, this is just a slide out of one of our presentations. It's just another example of how ultrasound and leak detection, we're working with a client and doing a leak survey across their compressed air system, found 203 leaks. And when we use the kind of standard leak ROI calculator, in this case, it was a UE systems calculator. You plug in the dB level, the pressures, and it gives you kind of an estimator. It worked out to be about $110,000 of annual energy savings when we determined the correction for all of these leaks. You start talking about annualized savings of $110,000. That helps get funding. It helps get benefit, and this is just one. I think this in this case was a multi-day. I think it may be in a multi-week inspection, but it returned a nice, healthy ROI. Another thing that I always talk about when we're talking about integration and making technology choices is that repair versus replace, and it's important to understand the distinction: a repair asset versus a replace asset. There's a lot of assets that we manage, and some may be critical, that we would never repair. We treat them as consumables. So it may be a small motor gearbox combination driving a critical process. But that small motor gearbox, if it fails, is critical. So we want to monitor it. But if it fails, we're just going to yank it out and grab one off the shelf and put it back in. And we're not going to affect the repair. If we don't affect the repair, we don't need very detailed analysis. So if we don't have that detailed analysis, then maybe we can substitute a more higher cost technology like vibration with a lower cost technology like ultrasound or infrared. Again, you have to worry about lead times in those cases, but in general, we want to use the best technology to accomplish our goals. And if our goal is to monitor replace assets, then go, no go, or good versus bad is really the goal of that, because you don't need a diagnostic. So when you're integrating a program, and we try to do this a lot in our services, is maybe deploy multiple technologies. And I mentioned before a conveyor system. We may use vibration on the large motor gearbox that's driving a large conveyor system, and then maybe use ultrasound or infrared to scan the bearings to identify either lubrication or hot bearings and or bearing problems. But we're deploying that as an integrated program. So, our technician would go out and he'd go through the facility and hit all the vibration points, put his data collector down, and then go back through the facility with either a camera or an ultrasound gun. And we can do hundreds of bearings with ultrasound versus the time it takes to do those same bearings in a vibration approach. So we're really trying to make the most out of the technologies, but this repair versus replace really has to be part of the decision-making process. So when we get to the bottom of that, then we'll go through all those steps. It's time to implement, and now it's time to determine how often we implement it. And again, one of the things that I always look for is I want to see different critical assets being treated differently. I don't think, I know assets don't fail the same way, so they shouldn't be monitored the same way. So we want to see frequencies that fit the asset type and the PF curve intervals that we have on those asset types. So, coming up with some type of formula calculation, however you want to approach it, so we can categorize equipment and deploy our programs that fit that frequency model. And a large number of cases that may be things that you do more frequently, like vibration monitoring on rotating assets or oil sampling, those type of things. How often do we need it to be effective in monitoring those failure modes? I mentioned this earlier, I'll just touch on it briefly. Integration doesn't mean that it all has to be one way or the other. We can have a complete outsource integration program, somebody to do it for you. You can have it completely in-house, where you're just doing it yourself, and then a hybrid program where you're using a combination. So sometimes integration can be accomplished by just leveraging other expertise outside your organization, but with the ultimate goal of integrating all the results into a common platform. A couple examples before we finish off. This was that particular example that I showed on the little eye chart with the green box around it, where we had motor testing, oil analysis, and vibration monitoring on a cooling tower fan and motor. So in this case, the first set of data that was collected was a motor test, and the motor test failed because it was exceeding its full load amps. It was about 102% of the full load amps. So the recommended action was, to check the fans, check the fan pitch for proper adjustment, and then if they were proper, consider balancing the fan or checking the alignment. So looking at the motor draw, and it was drawing, it was overamping. Something was causing it to pull more load. If we balance that, now looking at that alone, we're kind of okay. We have a kind of a laundry list of things to check. Now we look at the oil sample on the gearbox of the cooling tower, and that was done in close proximity to the vibration analysis, and the indication was there was high particle wear, rubbing wear, but they looked at the motor test where they saw high amp draw and suspected that there was an unbalance going on that was creating some wear inside that gearbox. They recommended a vibration inspection. Vibration inspection showed a high unbalanced condition. So if we look at each one of those separately, we're not necessarily guessing, but we're making decisions based upon the data that we have at that moment in time. If we integrate them all together and start looking at them collectively, it's really going to help us pinpoint, be more effective, minimize the repair actions, the maintenance actions, lower our overall cost, and get corrective and get back up and operating in the shortest intervals. So this is just one example of where the integration can help. And then I've shown some outputs of criticality and failure modes. This is a bakery manufacturer, and you can see their assets on the left-hand column. Going down each row is an asset, and then our technologies in the columns, the last 5 columns. So as we've gone through the failure and criticality and failure mode analysis, then we started diagnosing where we wanted different technologies to play and at different frequencies. When we go through that, the output is our integrated PdM program. Another example, this is a manufacturer. It's in this case, it was multiple sites. So they had sister units. So we spent a lot of time at one site, kind of got a deployment model that we could replicate at other sites because their processes were almost sister. Not all the equipment was identical, but it was close enough that we could work through that deployment model, and criticality would be similar, and our deployment model would be similar. But again, we're looking at things that are critical, and then what is the prescribed methodology to affect monitoring of those failure modes. Just notice the gray area, in the gray shaded area. In this case, those assets were category D assets in that 5-category matrix that we saw earlier. D and E category were not applicable. So the document here automatically just made those not available to the different technology choices. So once we get the criticality, we're going to just automatically remove portions of the asset listing because it just isn't applicable to our PDM deployment. So in summary, the things that I'd like you to think about as you move on the rest of your day, and looking at your current PDM strategy, or if you're looking to deploy a PDM strategy, the integration really helps drive our PDM programs to be more successful. It's giving us a more complete picture of the health of the asset. Done properly, done with maybe a little bit more upfront investment, but designed properly can lower your overall deployment costs long term. That enhanced analysis and diagnosis ability is really going to give us better pinpoint accuracy to right size the maintenance and the corrective action. And that's a real big issue for a lot of folks. That one of the bad things about predictive maintenance is if we're not 100% sure, and then we say, well, okay, I think it's this, go out and replace the bearing, and the maintenance team goes out and pulls the bearing, and they do an examination of it, and it looks brand new. The program takes a pretty big black eye. And those are real examples where people challenge the effectiveness of the PDM. They may not be true believers or truly educated on the technology, but they'll challenge the effectiveness and say it's witchcraft, it's hocus pocus, whatever the terminology they want to use. The better we can diagnose and analyze and really find the problems, the more people will adopt that the recommended actions we're prescribing are accurate and should be trusted. I just think overall, when I've seen integrated programs, I see people working better together. When we run programs in silos, well, I do the vibration and Frank does the infrared, and we don't really talk very often. I just think that enhanced communication and the ability to pull that information together is invaluable. And it does take more effort. So if you're happy with where your program is, you're not looking for that program to take the next step, then we just spent an hour together listening to me talk and probably aren't going to take it much further. But as you look at your programs, whether it's a new deployment or whether you're looking to enhance this is one area. It's not the only area, but one area that can enhance the effectiveness of the program. And with that, I'm going to turn it back over. And just before I do, I'm going to offer my thanks for everybody to take time out of their busy schedule and listen to the presentation, and hope you found the information valuable to your operation.
All right. Thank you so much, John. At this time, we're going to open up for any questions. We do have a few here. All right. Integrated analysis is certainly desired. However, in my experience, a challenge is that the third-party contractors offer one, maybe two of these technologies. A lab that does oil analysis does not offer vibration analysis. A vibration analysis company does not offer ultrasonic. This leads to increased costs. That should not be a concern, but often is. My question is, are there tools, companies that offer multiple technologies?
Well, I don't want to make it a commercial for predictive service, but you just teed me up, so I will. We are one of those unique companies, and there are others out there. I don't want to minimize that there are others out there, but the tools that I've used, the screen captures I used, our technicians that are in the field are trained multiple disciplines. The only caveat I'll make, and we're not an oil lab, but we'll facilitate oil collection, and we partner with folks like Insight. Insight's our and Test Oil. They're our primary lab, and they provide us results from the sample. They also provide it to the client directly, but they provide it to us, and then our analysts in our office take those results with all the other results and integrate it into the reporting platform. They both do the integrated analysis and then the integrated reporting. So I appreciate the comment, because there are limitations to some providers out there, but there are people like Predictive Service that can bring a wider breadth of capabilities and technologies to the table. And we spent a fair amount of effort training our resources in multiple technologies. It's not easy, but in order to deploy the model that we deploy, we couldn't show up with 4 guys getting out of a car and then doing the inspection. To make it cost effective for both us and the client, we had to make sure that the resources was capable to do multiple disciplines.
All right, thank you. Second question. All right. Should the PDM program be done on the asset or spare parts level?
Well, I think it can be both, especially we have a client, just as an example, that it's a pipeline client. They have multiple pumping stations over a vast geography. They have a lot of their motors in inventory up and down this pipeline. And we routinely, or they contract us, but we do an MCE test on their motor, because one of the things you've got them in inventory, maybe you're doing the proper care while it's in inventory, you're turning the shaft, you've got it pretty well sealed, those types of things, but you're hoping that that's in good condition, on the shelf. And the only caveat I give you on the spare parts, you're really going to take that to your critical assets, because you want to know that spare is ready to go and fit for duty, and not hope if it's on a critical asset. So there are techniques and there are things that we should do to the spares, but a lot of them isn't technology related. It's more care, handling, sealing, controlling it from the environment, temperature, humidity, things like that, rotating shafts. So there are things we want to do to spares, but not all of the time it's PDM.
Okay, next question here. How have you seen anyone effectively integrate the results of multiple technologies without the results of those technologies being in the same database? Example, RBM where, Meridrum, etc.
Yeah. It's tougher, but to be honest, the slides that I showed you, our viewpoint is a reporting platform. So the vibration would go into its native database. The infrared goes into the infrared goes directly into our viewpoint, but it may go into a FLIR database or a Fluke database. Obviously, the oil analysis would go into your laboratory vendor, and so we don't focus as much on integrating it into one database on the back end or at the raw data level. We focus on integrating the analysis. So our guys typically will have multi-screen on their PCs. They'll have their vibration signatures on one. They may have their motor testing on the other screen. They're really reading out of two databases. But where we then bring it together is once that analysis is done out of those databases, the reporting is integrated. So the raw data for us, and it's the biggest challenge. How do we get one database to handle all of that data? It's a huge challenge. We didn't solve that. We just worked with the raw data and then integrated the results.
All right, next question here. On the performance failure, will you run a PdM program if it is low frequency but high cost?
I think it's always a balance. You may have a less critical asset, but it's the failure is high cost. It's that balance. Can we be effective at a lower frequency, but and be effective in determining the failure modes? The worst thing that we can do is deploy dollars or resources and costs to something and then fail to catch the actual failure. If we want to sync the PdM program the quickest, that's the way we do it, is we don't catch those problems. And PdM is not 100%. It's not going to catch everyone. There are some things that go bump in the night, and we're not going to predict them, but they're the biggest challenge for us, because once that happens, people come back and point the fingers at the PdM program and say, hey, you guys are supposed to be watching this. How come it failed and we didn't have notice? So it's that balance, and we have to look at every asset and every application and determine, is cost the biggest factor? Should we not worry about criticality, but worry about cost and replacement value? And then we'll include that. But then how often that we do it? It's not always easy. But I think when you set the program design, you want to set the goals. If the goals are, if a primary goal is to lower your overall maintenance cost year over year, then we would have to approach it in that aspect, and high net value assets have to be inclusive then.
All right, it looks like there are a few more questions, but I think they would be best answered through email. I'd like to thank everyone for joining us today, and thank you so much, John, for presenting for us.
Oh, my pleasure.
All right, thank you, and everybody have a good rest of your day.